Hello and welcome, new subscriber. We're thrilled to have you join our community here at Don't Peek Channel. Get ready for a journey filled with excitement, knowledge, and fun. As a subscriber, you'll be the first to access our latest videos, exclusive content, and special updates. We can't wait to share this adventure with you. Thank you for subscribing, and we look forward to sharing many incredible moments together. Today, we're diving into the fascinating world of how it works. From the marvels of technology to the mysteries of nature, we'll explore examples that shed light on the inner workings of our world. Join us as we unravel the mechanisms behind everyday phenomena, uncover the secrets of cutting-edge innovations, and delve into the intricacies of natural processes. Get ready to expand your understanding and ignite your curiosity as we embark on this journey together. Let's dive in and discover the wonders of how it works. Number 1. How does a microwave work? A microwave oven works by using microwave radiation to heat food. Inside the microwave, there's a component called a magnetron, which generates microwaves. When you set the cooking time and turn on the microwave, the magnetron produces these microwaves, which are then directed into the cooking chamber. Microwaves are a form of electromagnetic radiation, similar to radio waves, but with a higher frequency and shorter wavelength. When these microwaves encounter food, particularly foods with high water content, such as fruits, vegetables, and meats, they cause the water molecules within the food to vibrate rapidly. This rapid vibration generates heat, which cooks the food evenly and quickly. The energy from the microwaves is absorbed by the water molecules, causing them to move faster and collide with other molecules, thus increasing the temperature of the food. The microwaves penetrate the food, heating it from the inside out, unlike conventional ovens that heat food from the outside. This is why microwaves can cook food much faster than traditional methods. Additionally, because microwaves only heat the food and not the surrounding air or container, they are also more energy efficient. The rotating turntable inside the microwave helps to ensure even cooking by continuously moving the food around, exposing it to the microwave radiation from different angles. Overall, the mechanism of a microwave oven is based on the conversion of electrical energy into microwave radiation, which in turn heats the water molecules in the food, cooking it quickly and efficiently. Number 2. How does Wi-Fi work? Wi-Fi, short for wireless fidelity, is a technology that allows devices to connect to the internet or communicate with each other wirelessly within a certain range. Here's a breakdown of how Wi-Fi works. Radio waves. Wi-Fi operates by transmitting data using radio waves. These waves are similar to the ones used by radios and televisions, but at much higher frequencies. Wireless router. At the heart of a Wi-Fi network is a wireless router. This router is connected to an internet source such as a modem and acts as a central hub for transmitting data to and from connected devices. Network interface card, NIC. Devices like smartphones, laptops, and tablets are equipped with a network interface card, NIC, that allows them to send and receive data wirelessly. This NIC communicates with the wireless router to establish a connection to the Wi-Fi network. SSID and password. Wi-Fi networks are identified by a Service Set Identifier, SSID, which is essentially the network's name. When you want to connect a device to a Wi-Fi network, you select the network's SSID and enter the password if the network is secured to authenticate and establish a connection. Data transmission. Once connected to the Wi-Fi network, data can be transmitted between the device and the router. This data can include web page requests, emails, video streams, and more. Frequency bands. Wi-Fi operates on two main frequency bands, 2.4 GHz and 5 GHz. These frequency bands provide different advantages in terms of range and speed. For instance, 2.4 GHz signals can penetrate walls better and cover larger areas, while 5 GHz signals offer faster speeds but have shorter ranges. Encryption. To ensure security, Wi-Fi networks can use encryption protocols such as WPA2 or WPA3. These protocols encrypt the data being transmitted over the network, making it difficult for unauthorized users to intercept or access. Range. The range of a Wi-Fi network depends on various factors, including the power of the router, obstacles like walls, and interference from other devices operating on similar frequencies. In summary, Wi-Fi works by transmitting data wirelessly using radio waves between a wireless router and devices equipped with a network interface card, NIC. This technology provides convenient internet connectivity without the need for physical cables, enabling flexibility and mobility in accessing online resources. Number 3. How does nuclear fusion work? Nuclear fusion is a process where atomic nuclei combine to form heavier nuclei, releasing a tremendous amount of energy in the process. Here's a simplified explanation of how nuclear fusion works. High temperatures and pressures. Nuclear fusion occurs under extreme conditions of high temperature and pressure, similar to those found in the core of stars like the Sun. These conditions are necessary to overcome the electrostatic repulsion between positively charged nuclei and bring them close enough together for the strong nuclear force to bind them together. Hydrogen isotopes. The most common nuclear fusion reactions involve hydrogen isotopes, such as deuterium and tritium. Deuterium is an isotope of hydrogen with 1 proton and 1 neutron, while tritium has 1 proton and 2 neutrons. When deuterium and tritium nuclei collide and fuse, they form helium-4, 2 protons and 2 neutrons, along with a neutron, and release a large amount of energy, mass energy conversion. The energy released during nuclear fusion comes from the conversion of a small amount of mass into energy, according to Einstein's famous equation E=mc². In fusion reactions, a tiny fraction of the mass of the original nuclei is converted into energy, resulting in a significant release of energy. Earth-based fusion. Scientists are working to replicate nuclear fusion on Earth for energy generation. This involves heating hydrogen isotopes to extremely high temperatures, tens of millions of degrees Celsius, to form a plasma, a state of matter where atoms are ionized and electrons are separated from nuclei. In devices called tokamaks or stellarators, magnetic fields are used to confine and control the hot plasma, allowing for sustained fusion reactions. Clean energy. Nuclear fusion has the potential to provide a virtually limitless and clean source of energy. Unlike nuclear fission, which produces radioactive waste and carries risks of accidents and proliferation, nuclear fusion produces no long-lived radioactive waste and carries minimal risks. It utilizes abundant sources of fuel, such as hydrogen isotopes found in water, and produces no greenhouse gas emissions. Number 4. How does quantum computing work? Quantum computing harnesses the principles of quantum mechanics to perform computations using quantum bits, or qubits. Unlike classical bits, which can exist in a state of 0 or 1, qubits can exist in a superposition of both states simultaneously. This unique property allows quantum computers to process vast amounts of information in parallel, enabling them to solve complex problems much faster than classical computers. In addition to superposition, qubits also exhibit another quantum phenomenon called entanglement. Entanglement allows qubits to become correlated with each other in such a way that the state of one qubit instantly influences the state of another, regardless of the distance between them. This property enables quantum computers to perform certain types of calculations more efficiently than classical computers. Quantum computers manipulate qubits using quantum gates, which are analogous to classical logic gates, but operate on quantum states. By applying sequences of quantum gates to qubits, quantum algorithms can perform calculations that would be infeasible for classical computers due to their exponential computational complexity. One of the most famous quantum algorithms is Shor's algorithm, which can efficiently factor large numbers, an important problem in cryptography. Another notable algorithm is Grover's algorithm, which can search unsorted databases exponentially faster than classical algorithms. However, building practical quantum computers faces significant technical challenges, such as maintaining qubits in a coherent state for a sufficiently long time, called coherence time, and minimizing errors caused by environmental noise and decoherence. Despite these challenges, advances in quantum computing hardware, software, and algorithms are driving progress toward the development of practical quantum computers. Quantum computing holds promise for revolutionizing fields such as cryptography, optimization, drug discovery, materials science, and artificial intelligence. Number 5. How does Bluetooth work? Bluetooth works by enabling wireless communication between electronic devices over short distances using radio waves in the 2.4 to 2.485 GHz frequency band. Devices establish a secure connection through a process called pairing, where encryption keys are exchanged. Once paired, devices can transmit data using frequency-hopping spread spectrum to minimize interference. Different profiles and services define the types of tasks devices can perform, such as audio streaming or file transfer. Bluetooth devices manage power consumption by entering various power states, and security features like encryption and authentication protect data during transmission. Overall, Bluetooth facilitates convenient wireless communication between a wide range of devices, making it suitable for applications such as wireless headphones, speakers, file sharing, and more. Thank you for watching. Don't forget to like and share our content to help us reach more people. Your engagement helps us grow our community and spread valuable information to others who may benefit from it. By liking and sharing our content, you contribute to fostering a supportive and informative environment for everyone involved. So, keep engaging with us, and together we can create meaningful connections and share knowledge far and wide.